This is an Aristotelian refutation of Newtonian mechanics, specifically a refutation of Newton's account of orbital motion as caused by only rectilinear forces. This is from the introduction to my recent translation of Proclus's Elements of Physics. And I included this in the introduction as part of a defense of Aristotelian physics. Now, Newton's account of the curvilinear motion of the planets as caused by only rectilinear forces is most significant to the tension between Aristotelian physics and the new science of the 17th century. Because Aristotelian physics, from that distinction of curvilinear and rectilinear motion, drew the distinction between the substance of the heavens and the substance of the elementary bodies and their composites. And from there is drawn the proof of the unmoved mover and the eternity of the circular motion of the heavens. So Newton's attempt to account for curvilinear motion of the planets by only rectilinear forces is deeply significant and has been overlooked, for people have not perhaps even noticed that Newton's Principia and those very first proofs therein are attempting to establish just that. So I'll read from this portion of the introduction, which I wrote. Although I have briefly presented Newton as somewhat of an exception to the rule that syllogistic reasoning and proofs are absent from modern physics and mathematics, since his Principia Mathematica consists entirely of geometric proofs and appears to be axiomatically structured, what makes his work seem like less of an exception to the rule is that he jumps immediately into complexities, which we shall find to be a sort of sophism, if not simply a lack of ability in argument. And that in doing so, his prior most inferred conclusions are reached by questionable and obscure maneuvers, employing concepts that would never be accepted by anyone who is not already on board with his project. We find again that where there is not any opposition, what passes for proofs can hardly even be considered arguments. There is no punch to a conclusion that is obscurely reached. And there is no punch to a conclusion where the inference depends on a complex technicality. I mean, where someone that accepts the premises might still be confused about how the conclusion follows, or that the conclusion is then necessary. Such a maneuver occurs in Newton's very first proofs, upon which the rest of his arguments depend. Briefly stated, he attempts to prove that a planet always traveling upon rectilinear tangents. For his first law is that all motion continues along straight lines, and his second law that a force can only alter a motion rectilinearly. If the planet's motion is altered from one tangent to another, and then is altered again along another tangent, in infinitesimal parts of time, the planet moves as a whole curvilinearly. That is his primary argument. He thus resorts to the concept of infinitesimals because he can only account for the curvilinear motion of the planets if, as he says, a motion can only be altered rectilinearly by infinitesimal increments of rectilinear motions, the whole of which becomes curvilinear, when each increment of motion happens in infinitesimal times along different tangents. This concept of infinitesimals, of infinitesimal increments of a motion, which is Newton's primary device, is how he makes this argument. That concept was very contentious during the scientific revolution, and it had to be entirely revised by mathematics in the 19th century. Few scholars have noticed the significance of this maneuver, and indeed the significance of his mechanics in general, because perhaps they have not the perspective of Aristotelian physics, or are unfamiliar with the previous paradigm which Newton was attempting to overthrow and avoid. Why did he insist that a motion can only be altered rectilinearly, and that anything in motion continues moving rectilinearly? And why then was he required to resort to the concept of infinitesimals and infinitesimal increments of a motion in order to account for the curvilinear motion of the planets? That is, why was he forced to conceive of the curvilinear motions of the planets as being composed of infinitesimal rectilinear increments of motion? For his very first proofs in section 1 of book 1 attempt to establish just that. The answer to those questions is that he was attempting to overthrow and avoid Aristotelian physics. For the distinction between curvilinear and rectilinear motion is fundamental to the Aristotelian paradigm and is fundamental to the proof of the existence of the unmoved mover. An Aristotelian, however, would ask this: does his conclusion that the planets move curvilinearly necessarily follow from, or is it rather refuted by, his premises that their motions can only be altered rectilinearly, and that their momentum will always continue in a rectilinear direction? From those premises, which indeed are his first two laws of motion, the curvilinear motion of the planets is rather something impossible. In fact, if his geometry contained any inference or proof whatsoever, which in order to even account for curvilinear motion it does not, but rather slyly avoids, the obvious and only inference, given the premises, would be that there is no curvilinear motion. Hence, he resorts to the mathematical technicality that itself is questionable in order to establish the curvilinear motions of the planets in contradiction to his first two laws, as if to avoid the only inference about the motion of the planets that obviously follows from his premises, rather than is to make any inference at all. As the point I made in the previous section is that we find not the sorts of inferences which we do of syllogistic reasoning, the sort of weight that a conclusion has when given the premises the conclusion follows by necessity, is absent from this sort of thing. For Newton, in establishing the curvilinear motion of the planets, makes not an inference from his premises or his first two laws that a motion can only be altered rectilinearly, and that everything continues moving rectilinearly unless it is altered again, in which case it is altered only in a rectilinear line. Given those premises, if he were to draw any inference, that would be that that there is no curvilinear motion. But he is not making an argument. He is not drawing an inference. He is not inferring a conclusion from premises. He establishes the curvilinear motion of the planets not by an argument such as a conclusion that's inferred with some sort of punch, with some sort of weight, but by a mathematical technicality. That is why that doesn't look like an argument. That's why the conclusion seems to be a contradiction of the premises, because these infinitesimal increments of rectilinear motions assumed to compose a curvilinear motion when taken as a whole is a mathematical technicality, and a problematic one at that. Again, we find the workings of someone unfamiliar with and placing no value on inference or proof and refutation. His maneuver in the very first proofs of that work is to say, suppose now that the tangents along which the motion of a planet is only ever directed, that they're diminished in length and increased in number ad infinitum. The course described by the planet will then be curvilinear. In a word, the motion of a planet, which again can only be altered along a rectilinear tangent, approximates a curvilinear path when the tangents are diminished into infinitesimal lines, when they are decreased in length and increased in number ad infinitum. Then they, quote unquote, approach a curvilinear motion. But is each infinitesimal distance rectilinear? For the motion cannot be curvilinear, of which each part is rectilinear. Are these infinitesimal distances rectilinear? Is every part of a curvilinear motion then a minuscule rectilinear motion? What even is an infinitesimal? What is an infinitesimal distance? A distance at all? And does any time pass in a nascent sliver of time in which the planet moves in infinitesimal distance? And why then can a motion only be altered rectilinearly? Why does that then remain as his first principle? Or one of his laws of motion? In any case, there is nothing clear and distinct about those questionable concepts, nor about that maneuver. There is something forced as an unnecessary intrusion in both demanding that a planet can only be altered rectilinearly, demanding that the motion of a planet can only be altered rectilinearly, and in demanding that every part of a curvilinear motion is an infinitesimal rectilinear motion, which we shall find to be nothing else but his attempt to maneuver around Aristotle's doctrine, that the circular motion of the heavens distinguishes them in kind from the bodies that move rectilinearly, such as earth and fire. That their circular motions are eternal and caused by an eternal unmoved mover, whereas bodies that move rectilinearly are moved by mutable forces. That is what Newton is trying to overthrow. Why the use of the concept of infinitesimals is something that jeopardizes his whole work relates to the structure of a composed sequence of theorems, which is what he was aiming at. The axioms are required to be self-evident, or at least not up for dispute. And the first proofs are required to be absolutely certain and to follow necessarily from the axioms, to be non-controversial. else the remaining theorems, which have as their premises the conclusions of previous proofs, cannot be considered demonstrated. Thus, we are justified in asking, along with George Berkeley, whether there can be science of the conclusion where there is not evidence of the principles, and whether a man can have evidence of the principles without understanding them, and therefore whether the mathematicians of the present age act like men of science in taking so much more pains to apply their principles than to understand them. For Berkeley's book, entitled The Analyst, in which we find that passage, was directed against the questionable procedures of the infinitesimal calculus, not just as used in mathematical calculations, but specifically against their appearance at the foundations of Newtonian mechanics. That also has not been pointed out by scholars, that Berkeley's Analyst, in which he calls infinitesimals the ghost of departed quantities, and refutes through and through both the concepts, refutes that there is any clarity in the concepts of infinitesimals and used by the infinitesimal calculus, and that the procedures are contradictory. George Berkeley cited the Principia Mathematica, which is what I'm trying to refute, which is the basis of Newtonian mechanics. Berkeley cited that work a number of times in his Analyst, which is seen as a valid critique of calculus. But Newtonian mechanics, which these theories are indeed still used in quote-unquote celestial mechanics. These aren't outdated. Newtonian celestial mechanics, as far as I can tell from the contemporary literature, is not something that is outdated and irrelevant, but has never been scrutinized for the use of infinitesimals. Among the points also that I'm raising, but even just about that, when the infinitesimal calculus had to be reformulated to be established rigorously, which I claim it was not, and absolutely did not meet George Berkeley's standards, Newtonian mechanics, which uses those concepts of infinitesimals, was not subject to the same scrutiny, was not reformulated. And Newton's account of curvilinear motion as caused by only rectilinear forces is not irrelevant in this day. I should say that I will provide a formal refutation of a reductio ad absurdum, or a double reductio ad absurdum, in the form of the sort of arguments which Zeno of Elea makes near the end of this recording. But the context has to be provided before of why these are significant, why we're arguing that the curvilinear motion of the planets cannot be caused by rectilinear forces. There's so much that is intrinsically connected to that, including the proof of the unmoved mover. Thus, anybody reading Newton's Principia who is not ready to admit that every part of a circular motion is an infinitesimal rectilinear motion, or that the luminaries are always moved rectilinearly on tangents to their circular orbital paths, but are adjusted along different tangents in each infinitesimal part of the time of their motion. Someone who is not convinced of that by his priormost geometrical proofs, cannot possibly be convinced about the rest of his project or his account of celestial mechanics. And that peculiarity, I mean the proposition that the curvilinear motion of the luminaries is caused by forces which only impart motion rectilinearly, is not unique to his theory of gravity. It is absolutely inseparable from the primary cosmological contention raised by the new science. Since the doctrine of Aristotle was that the circularly moving bodies are composed of a different substance than the mutable elements in their composites, and that they move in circles eternally around the earth. In order to displace the earth from the center, and to make both the sun and the fixed stars stationary, the most fundamental challenge for the new science was to render the heavenly bodies indistinct from the composite bodies and the elements down here. And in order to establish a homogeneity of substance between the luminaries and the sublunary bodies, they were first required to argue that their motions are not categorically distinct, that the luminaries don't move naturally in circles, for on those grounds was a distinction drawn between the substances of the ethereal and the sublunary bodies. Else the sun and the fixed stars could not be accepted to be stationary, and the earth in circular orbit. To establish a theory that the luminaries are impelled by forces that act on them rectilinearly, and that the impulse of their motion, or their momentum, is always only rectilinear, would obviously be seen as a solution, allowing for the earth to have the sort of motion which the luminaries have, and that the sun and the fixed stars are stationary. Yet, mind you, the planets still move curvilinearly in both models. For otherwise, the same laws of motion and the same forces that act upon bodies upon the earth could not account for the uniform circular motion of the luminaries or any curvilinear motion of them, if that is something. They would have to be moved by a divine force. The planets moving curvilinearly would have to be moved by a divine force, or themselves be of a divine substance, if they can't be accounted for by rectilinear forces. Those motions can't be accounted for by the same rectilinear forces. And that goes for either cosmological system. For even with the sun and fixed stars stationary, the curvilinear motion of the planets had to be accounted for by rectilinear forces, by the advocates of the new science. That is entirely the aim with which Newtonian mechanics was tasked. It is not uncommon for scholars to point out his use of the infinitesimal calculus in the Principia, but never do they discern the crucial position that technical mathematical procedure has in his conceptual argument, nor that, given his premises, the curvilinear motion of the planets would rather be refuted than accounted for without the concept of infinitesimals. The scholars often have pointed out Newton's use of the concept of infinitesimals in his Principia, in the first book, his first proofs in the Principia. But they do not highlight what important role they play in his argument that he's making by those geometric proofs. And that otherwise, without the concept of infinitesimals, without infinitesimal increments of a motion, his first two laws, that motion can only be altered rectilinearly, and that everything in motion continues moving rectilinearly unless it is altered, in which case it again is only altered in a rectilinear direction, would rather refute there being any curvilinear motion. His the only inference that can be drawn from those laws of motion are that there is no curvilinear motion. Thus, he contrives the device of infinitesimal increments of a motion in order to account for curvilinear motion, in order to account for there even being anything that moves curvilinearly. But we have seen that that technical maneuver, that technical mathematical maneuver, is not an inference, does not result in a conclusion drawn from premises. Rather, is a way of avoiding the conclusion that would be the natural inference that follows necessarily from his premises of things only being altered rectilinearly and always continuing rectilinearly unless their motions are altered, in which case, again, they would only be set in motion rectilinearly. That the infinitesimals are his crucial maneuver. No scholars point out. Again, Aristotelians thought that the circular motion of the luminaries is no less natural to them than is the upward motion of fire. That is, the very substance of fire is such as to tend upwards, perhaps due to being light and without heaviness. And that is the very substance of earthen bodies is such as to tend downwards, due to their heaviness. So also the ethereal substance of the heavenly bodies is such as to move circularly without being pushed by an external force. Figures like Galileo and Newton were set towards contending that the heavenly bodies are not of such a substance as to move naturally in a circle, but that they are pushed by an external force, no differently than how earthen bodies are moved by constraint laterally or upwards. Congruently, they had to argue that earthen bodies don't tend downwards because of the sort of substance they are, or because the sort of substance they are has the essential attribute of weight, but that they are pushed downwards from without, no less when they fall downwards than when they are propelled upwards or laterally against the impulse imparted to them by their heaviness. In a similar manner, they had to account for the circular motion of the luminaries by some sort of external pushing imparted to them only rectilinearly. And they had to establish a way in which the bodies that move circularly may always only have rectilinear momentum, and how they may always really be moving along rectilinear tangential lines, such that their motion as a whole might be curvilinear. That is the puzzle which Newton's theory of gravitational attraction and the whole of Newtonian mechanics was meant to solve. That is, how to account for the circular motion of the luminaries, or the curvilinear motion of the luminaries, if you like, by some sort of external pushing imparted to them only rectilinearly. That's the challenge that Newtonian mechanics was meant to solve. For the Copernican cosmology, if it was to be anything more than a mathematical model, and was to be grounded in accompanying physics and mechanics, depended upon that conceptual reformulation. The scientific revolution was at that stage in the 17th century no further developed than an interim provisional government, being without determined physical or mechanical laws, but with all up for grabs. Hopefully this paragraph isn't a diversion, but I want to set the context. As of yet, or at that time, the Copernican system was but a mathematical model which claimed to exceed the Ptolemaic model by virtue of its simplicity, specifically for not having to account for retrograde motion, for not having to account for the retrograde motion of the planets. As the Copernican model did not claim that the Ptolemaic Ptolemaic model erred as to any predictions. The fault of the Ptolemaic model was not in its inadequacy to predict eclipses or to predict the positions of the planets at any time. Or anything like that. The Copernican model claimed to exceed the Ptolemaic by virtue of its simplicity for not having to account for retrograde motion. That is all. But the Copernican model was simultaneously accompanied by a tenfold complexity in other respects. For a planet that appears to be positioned in a certain zodiacal sign, or a certain place along the ecliptic, according to the Copernican model, is really in another zodiacal sign, but appears to be there from the perspective of the Earth, which is itself in a zodiacal sign, and when moving to another sign produces the appearance of the planet in question moving to another sign, while the planet in question is really moving to and from altogether different zodiacal signs than it appears to from the perspective of a moving Earth. Hence, if the retrograde motion of Mars, which appears from the Earth as Mars moving towards the west through the zodiac, under the Copernican model, Mars is not actually moving eastward through the zodiacal signs. Is positioned in the same place, but appears to be moving through different zodiacal signs because the Earth is moving to the left or to the west or to the east. That's the according to the Copernican model, a planet like Mars appearing to move to the right through the zodiac, from one zodiac sign to another, is merely an appearance caused by the motion of the Earth's west or left through in the other direction through the zodiac. Where for the Ptolemaic model, the position of Mars is where it appears to be. Recall again that their prediction, the ability to predict the positions of these things is not the point of dispute. Thus, in the Copernican system, a planet's apparent changing position is not just relative to the fixed stars, which are the only celestial coordinates, but is relative also to the changing position of the Earth. Thus, again, a planet appears to be moving westward through the zodiac when the Earth is moving eastward, and appears to be moving, but the planet is also moving through the zodiac. Thus, there's a composite that you can never tease apart. The motion of the planets through the Copernican model is their apparent motion is a composite of their actual motion, for they are moving through the zodiac. They are moving through the ecliptic, along the ecliptic. But they are also made to appear to move, sometimes when they are not thus moving as they appear, because the Earth is in motion, and from different parts, from different places, they appear to be in different zodiacs. There's a complexity of appearances in the Copernican system that the mind boggles to record determinatively in star charts. You would in fact need to record one star chart of their apparent positions, which would correspond to the geocentric, and then translate that into another chart through complex mathematical procedures amidst dizzying appearances, which would show their actual position according to the Copernican model. But you could not go directly from the apparent changing positions of the planets relative to the zodiacal fixed stars to a chart of their actual positions according to the Copernican. In other words, you can never observe their position, the positions of the planets, or their changes in position within the Copernican model. since according to that system, their positions are otherwise than they appear. And their apparent changing positions are a compound of both their real motions and their additional apparent motions due to the motion of the earth, things which cannot be teased apart. This is the complexity of the Copernican model, which is the sort of give and take that they have, along with the simplicity of the Copernican model for not dealing with retrograde, not having to account for retrograde motion. Likewise, in order to predict the apparent position of a given planet at a given time, you'd have to make a difficult step from what zodiac sign they ought to really be positioned in according to the charts corresponding with the Copernican model, and accounting them for what sign the Earth ought to be positioned in, to determine in what other sign the planet ought to appear relative to both the stars themselves and the variable position of the Earth. Using the Copernican model to design a calendar would thus be a task too complex and difficult even to attempt, since the additional variable of the Earth's changing position makes for charting the positions of the planets without translating them first into the geocentric model too complex and difficult even to attempt. Thus, it is no surprise that no calendrical system has ever been set to the Copernican model to this day. This is all because the celestial coordinates, i.e. the latitudinal and longitudinal positions of the fixed stars, which are themselves invariant, and set against which the varying positions of the luminaries can only ever be discerned. They are geocentric, those coordinates, and are deemed a false appearance according to heliocentrism. But let that not be a divergence from our immediate focus. I mean, only to set the sort of context. That is to say that as the Copernican advocates did not even dare to claim that the Ptolemaic model erred at all regarding predictions of the apparent positions of any of the luminaries. If the Copernican model was to correspond with the real celestial motions, the aforesaid conceptual difficulties in physics and mechanics would have to be resolved, and such was the task of Newtonian mechanics. Newton's solution to the difficulty of accounting for the curvilinear motion of the planets by only rectilinear forces was that the rectilinear force pulling them towards the center of their orbital path, the rectilinear force pulling them towards the center of their orbital path was such as to adjust their rectilinear momentum along a tangent to the direction along another tangent, again rectilinear, so that their tangential rectilinear momentum is always compounded with the force pulling them towards the center of their orbit, producing a compound motion along another rectilinear tangent of the circle. But that their momentum is adjusted from one rectilinear tangent to another by the force pulling them towards the center so often and in such minute, infinitesimal, nascent parts of time that their motion as a whole is curvilinear. And from hence arose his inclusion of infinitesimals, or of infinitesimal increments, in the very first theorems of his Principia Mathematica. For only by the concept of infinitesimal increments could he account for their circular motion or curvilinear motion by a conjunction of rectilinear momentum and a rectilinear gravitational force which alters the momentum. The rectilinear force adjusting their rectilinear momentum tangential to their orbital paths as to correctively set their momentum along another tangent, also rectilinear, and again to adjust their momentum along another tangent, so that they're always moving rectilinearly, but in minute increments, while their motion as a whole is curvilinear. For that reason, Newton was forced to introduce infinitesimals in his priormost theorems of his Principia, for they really are foundational to his accounting for the curvilinear motion of the luminaries by a compound of only rectilinear forces. As his crucial maneuver of composing curvilinear motion from forces that impart only rectilinear motion is inseparable from the concept of infinitesimal increments. Because again, his premises, his first two laws, his principles are that a motion can only be altered rectilinearly, and that a motion always continues moving rectilinearly, unless it is altered again, in which case it will only be altered rectilinearly. He is only then able to account for curvilinear motion, for the curvilinear motion of the planets, by the concept of infinitesimal increments, that their rectilinear motion is incrementally adjusted along different tangents of their curvilinear path, such as to, as a whole, compose a curvilinear motion. That is Newton's procedure. That has not been pointed out by scholars. Not even those who point out his use of infinitesimals in the Principia. But this that is his most significant argument he's trying to make. There's a lot of things he does in the Principia. But establishing that there are no curvilinear forces, or ruling out the possibility of curvilinear forces, and yet not ruling out somehow, contradictorily, curvilinear motions. Something he can do by only resulting to the concept of infinitesimal increments. Which again, if an infinitesimal is of any span, the motion will always be curvilinear, always be rectilinear. If one of those infinitesimal increments along which a planet is moving is of any span, the motion of the planet over that distance will be rectilinear. And a curvilinear motion cannot be composed of motions, every part of which are rectilinear. This is incredible difficulty here. Likewise, those who do not accept that circles are composed of infinitesimal rectilinear lines. Those who do not accept that a whole circular motion can be compounded out of parts, each of which is rectilinear, cannot even possibly be convinced of his account of orbital motion. I ask again whether conclusions obtained from obscure concepts ought to be considered proven, and whether those are even arguments, where the conclusion is not so much inferred from the premises and does not follow as an inference that necessarily follows from the premises, but is established by an questionable mathematical maneuver, almost as to attempt to infer the contradiction of the premises. For how else could curvilinear motion be accounted for by only rectilinear forces? George Berkeley made the same critique in the following passage. Although momentaneous increments, nascent and evanescent quantities, fluxions and infinitesimals of all degrees, are in truth such shadowy entities, so difficult to imagine or conceive distinctly, that to say the least, they cannot be admitted as principles or objects of clear and accurate science. And although this obscurity and incomprehensibility of your metaphysics had been sufficient to allay your pretension to evidence, yet it hath, if I mistake not, been further shown, that your inference are no more just than your conceptions are clear, and that your logics are as exceptionable as your metaphysics. It should seem, therefore, on the whole, that your conclusions are not attained by just reasoning from clear principles. Consequently, that the employment of modern analysts, however useful in mathematical calculations and constructions, doth not habituate and qualify the mind to apprehend clearly and infer justly. As again from Berkeley's Analyst. Now I will skip a section that is a sort of interlude and continue with the next section that is a more formal refutation of Newton's account of orbital motion as caused by only rectilinear forces. And here becomes evident the significance of the first book of Proclus's Elements of Physics and the sixth book of Aristotle's Physics. For the conceptual peculiarities raised by infinitesimal increments of a motion ultimately point towards the dilemmas which Aristotle and Proclus resolved in those books, regarding the infinite divisibility of anything continuous and the impossibility of discrete motion and motion at an instant. This will not get in the way, but the reason I mention those is because this is part of an introduction to my translation of Proclus's Elements of Physics. Hence, Proclus is vindicated for making precisely those topics the foundations, or rather principles, of a science of motion. For when we pull at the thread of Newton's statement that the orbital paths of the planets are composed of infinitesimal rectilinear line segments, along which their motions are altered in infinitesimal slivers of time, we find that the question comes down to the infinite divisibility of continua and the possibility or impossibility of discrete motion. But those topics, which are the true principles of any science of motion, are never directly mentioned by Newton. Consider, we are told only by Newton that when the rectilinear tangents along which a planet moves are decreased in length and increased in number ad infinitum, the whole motion of the planet will be curvilinear. But that begs the question of whether the tangents are divided always into smaller rectilinear lines, since a line is divisible into smaller and smaller line segments but never into points, or whether the tangents are ultimately divided into indivisible points. And not only is an answer to that question required to understand what is meant by Newton's theory, but both interpretations result in absurdity and impossibilities. For the tangential lines must either be divided always into smaller rectilinear lines, but nonetheless always into lines, always into rectilinear lines, or they will ultimately be divided into indivisible points without any interval. But in the prior case, the motion will not be curvilinear. And the latter case, that the rectilinear tangential paths are divided into indivisible points, raises the question whether motion is discrete then, rather than continuous. For it seems that it would have to be, given, again, those two first premises, that a motion can only be altered rectilinearly. But Newton says nothing about whether the rectilinear lines are infinitely divisible, nor about whether motion is continuous or discrete. And those questions are more prior to, or more so principles than either the concepts of infinitesimal distances, infinitesimal nascent times, and infinitesimal increments of motion, or any other principle he assumes. Whether or not things continuous are infinitely divisible. That, I say, that has to be where the first principles of physics are. And we find that in the sixth book of Aristotle's Physics and the first book of Proclus's Elements of Physics. Again, if each tangent along which a planet's motion is altered and along which it has rectilinear momentum is of an interval of any distance, if each tangent along which a planet's motion is altered, and along which it has rectilinear momentum, is an interval of any distance, its motion will be rectilinear, not curvilinear. And if each tangent is not an interval of any distance, each tangent will be indivisible, an indivisible point, and its motion will be discrete, which is impossible, as I will show soon in the formal refutation. Now we're getting into the refutation, but not yet the formal reductio ad absurdum. And approaching the problem from another angle, this time from the principles. If continuous lines are infinitely divisible into smaller and smaller line segments, if continuous lines are infinitely divisible into smaller and smaller line segments, each rectilinear tangent of which a planet's orbital path is composed must likewise be a line segment with an interval of a certain distance. It must likewise be rectilinear. But since the planet must traverse that distance, and that distance is along a rectilinear line, its motion will not be curvilinear. While on the other hand, if lines are not infinitely divisible into smaller and smaller line segments, each rectilinear tangent of which its orbital path is composed will not be an interval of any length, but will be an indivisible point. And the planet's motion will then be discrete, not continuous. Since, again, motion can only be altered rectilinearly. So even claiming that the planet moves from one point to the point right next to it, or to any other point, the planet cannot move curvilinearly. Planet's motion, if you reduce them to points, will be discrete and will skip. I've repeatedly said that Newton's principles are 1, that a motion can only be altered rectilinearly, and 2, that everything in motion continues moving rectilinearly unless its motion is altered, which again would only alter its motion in another rectilinear direction. Those indeed are his first 2 laws, which are meant to rule out the possibility that the planets are moved by forces different from those which move terrestrial bodies by constraint. Those 2 laws are meant to rule out the possibility that the planets are moved by forces different from those which move terrestrial bodies by constraint. I have also repeatedly said that in order to account for the curvilinear motion of the planets, he is forced to say that the motions of the planets are incrementally altered in infinitesimal nascent slivers of time, and that they are moved along infinitesimal rectilinear tangents. Infinitesimals thus serve as an additional principle of Newtonian mechanics, as appeared also to Berkeley, which again, Berkeley in his critique of infinitesimals cites Newton's Principia, and that also is overlooked by scholars. For in Newton's first geometrical proofs, he attempts to show that the sum of the areas of parallelograms inscribed under a curve, although unequal in area under the curve, to the area under the curve. The parallelograms under the curve are unequal to the area under the curve. And quite obviously, that is admitted in the geometrical proof. But that they become equal to the area under the curve upon the parallelograms being increased in number and decreased in width ad infinitum. Upon that rests his claim that the tangents along which a planet's motion is altered, and along which it has momentum, may, by being increased in number and decreased in length, become parts of a curvilinear motion. This is maneuver. But no clarification is offered as to whether the motion is continuous or discrete, nor is it explicitly stated that continua are not infinitely divisible. For the motion of the planets to be curvilinear, however, given the premises, continuous lines could not be infinitely divisible, and motion could not be continuous. For, as we have seen, decreasing the rectilinear tangents in length would, if they are infinitely divisible, not change the fact that the planet is always moving along rectilinear lines. But if lines are not infinitely divisible, decreasing the tangents in length would make each tangent an indivisible point, and the planet's motion would then be discrete. Asking the reader to suppose that the rectilinear tangents are decreased in length and increased in number ad infinitum, and concluding that the motion over those tangents would then be curvilinear, after going to great lengths to lay down as a law that a motion can only ever be altered rectilinearly, and that the momentum of everything in motion is always rectilinearly. That cannot but beg the question whether the diminished tangents are infinitely divisible into smaller and smaller lines, nonetheless always into lines, or whether they are divided into indivisible points without length. We can perhaps infer that they could not be infinitely divisible into smaller and smaller line segments, since the motion over each of them would be rectilinear, and the motion over the whole could not then be curvilinear. But then motion will be discrete and not continuous, which is another problem of no slight significance, and which will be thoroughly treated in the formal proof. The meaning of his statement cannot even be interpreted without raising and answering those questions. And the meaning of his statement is neither outright and clear nor explicit. Oddly enough, assuming infinitesimals as principles reveals an absence of any principles, but simultaneously points directly to what the real principles of a science of motion ought to be. That is, whether things continuous are infinitely divisible. For from that, we are also able to prove whether or not motion can be discrete. George Berkeley's remark that the principles of a science cannot be unclear and indefinite would be appropriate to repeat. For as Plato relates to us in the Philebus, it is well to repeat good things twice and thrice over, as the proverb goes. Although momentaneous increments, nascent and evanescent quantities, fluxions and infinitesimals of all degrees, are in truth such shadowy entities, so difficult to imagine and conceive distinctly, that to say the least, they cannot be admitted as principles or objects of clear and accurate science. Although the concept of infinitesimals is unintelligible and indefinite, and therefore cannot serve as a first principle of any science of any worth, the very questions raised by such a notion point towards none other than what is, according to Proclus and Aristotle, the first principle of the science of motion, that is, the infinite divisibility of continua. For whereas Newton's first geometrical proofs used the concept of infinitesimals, the obscure concept, Proclus and Aristotle's first theorems proved that things continuous are infinitely divisible. If, however, lines are infinitely divisible into smaller and smaller line segments, but never into points or anything without interval, then the tangents along which a planet's motion is altered and along which it has momentum will never be divided into anything other than rectilinear line segments. And if a planet only ever has rectilinear momentum, and its motion can only be altered rectilinearly, then if the rectilinear tangents over which it is moved cannot be indivisible, but must be of a certain interval, the planet will always only move rectilinearly. It can never move curvilinearly. Thus, the conceptual peculiarities raised by infinitesimal increments of motion ultimately point towards the dilemma regarding the infinite divisibility of continuous things, the inherent concepts of which continuous, contiguous or touching, and consecutive or next in sequence comprise the first principles of the Aristotelian science of motion, as is made clear by Proclus in his Elements of Physics, and before that by Aristotle in the 6th book of his Physics, as well as, I should add, in his work on indivisible lines. And the mathematical contentions previously mentioned in the previous section regarding the same topic of infinitesimals especially come down to those same arguments. For in geometry, it is assumed as an unproved axiom that lines are infinitely divisible into smaller and smaller lines, and that lines can never be divided into nor composed of points. But that is proved in the first theorems of those very works by Proclus and Aristotle. Proclus and Aristotle, thus, in their physical works, set forth to prove the axioms of geometry, which are the points of contention raised by the idea of infinitesimals, or the composition of the continuum, which the infinitesimal calculus was always want to reconceive. That question was of central importance to Aristotle, for half of On Indivisible Lines refutes the claim that lines are composed of indivisible smallest line segments, and the other half of the same work refutes the idea that lines are composed of points, or that lines are divisible into points and not infinitely divisible. While his arguments in the 6th book of his Physics, which are reformulated by Proclus in the first half of his Elements of Physics, both prove that continuous things are infinitely divisible and refute the claim that continuous things are composed of indivisibles, whether those indivisibles be points or line segments. And the same question is given consideration in his On Generation and Corruption. And much of the rest of the first book of Proclus's Elements of Physics is spent proving the impossibility of motion at an instant and the impossibility of discrete motion, which are also problems that arise from the concept of infinitesimal increments of motions. But let us turn back to Newton's attempt to account for curvilinear motion by a composition of rectilinear momentum and the impression of only rectilinear forces, from the standpoint of Aristotle's proofs of the infinite divisibility of continua and his arguments against the possibility of discrete motion and motion at an instant. And let us see how well Newton fares from the standpoint of the 6th book of Aristotle's Physics and the 1st book of Proclus's Elements of Physics. For therein are the true foundations of any science of motion, which have never been overturned. This is the formal refutation. Suppose a given planet to have rectilinear momentum along a tangent of its orbital path. Let the rectilinear force pulling it towards the center of its orbit alter its momentum from one tangent to another. Again, suppose a given planet to have rectilinear momentum along a tangent of its orbital path. Let the rectilinear force pulling it towards the center of its orbit alter its momentum from the one tangent to another. That its momentum can only have been altered in a rectilinear direction is clear, for it is supposed that a force can only alter the motion of a body rectilinearly, and that the momentum of a planet is always along a rectilinear tangent. Now, the planet will either be carried a certain distance before its momentum is altered again to another tangent, or it will not. If it is carried a certain distance before its momentum is altered again, it will move rectilinearly, since its momentum is along a rectilinear tangent. But if it always moves some distance rectilinearly before its momentum is altered again, its whole orbit cannot be curvilinear, for it is impossible that a motion be curvilinear of which each part is rectilinearly. If, on the other hand, it is not moved a certain distance before its momentum is altered again along another tangent, no time could have passed, For if it was moving and had rectilinear momentum, if any time had passed, it would have moved some distance. But if it didn't move any distance and no time passed, then it must be at the same point. But since a tangent only touches a curve at one point, and no two tangents touch a curve at the same point, if it has not moved to a different point, it cannot have had its momentum altered along another tangent. For it can only have momentum along the tangent which touches the curve at the point it is at. It cannot then not have moved a certain distance before its momentum was altered again along another tangent. Therefore, whether it move a certain distance or no distance at all before its momentum is altered again, it cannot move curvilinearly. And if, while it is at one point, its momentum is along a given rectilinear tangent, when it is at one point, its momentum is along a given rectilinear tangent, and after having its momentum altered by the centrifugal force, it is then at another point, and its momentum is along another tangent. Between those points, there must either be some distance or not. If there is some distance between them, the planet will have had to have traversed that distance before reaching the second point. But it could not have traversed that distance while moving along the curve, since its momentum is only ever along one or the other of the rectilinear tangents, and its motion can only be altered in a rectilinear direction by the centrifugal force. It cannot then, between being at one point on the curve and having a rectilinear momentum along one tangent and being at another point with momentum along another tangent, have traversed any distance curvilinearly. Neither, however, could it have traversed the distance rectilinearly, for since a tangent only touches a curve at one point, and no two tangents touch a curve at the same point, its momentum along any tangent cannot bring it to any other point on the curve, for no tangent passes through the point at which any other tangent touches the curve. If, then, neither the tangent its momentum was altered from, nor the tangent its momentum was altered to, pass through both points, its motion can only have been altered rectilinearly. If then neither the tangent its momentum was altered from, nor the tangent its momentum was altered to, pass through both points, and its motion can only have been altered rectilinearly along another tangent, it could not have been moved from one point on the curve to another by having its momentum altered along another tangent. It cannot then, between being at one point with a momentum along one tangent and being at another point with momentum along another tangent, either have traversed the distance between the 2 points curvilinearly or rectilinearly. Now, suppose then that there is no distance between the 2 points on the curve. Supposing that there is no distance between the 2 points on the curve at which it has momentum along different tangents. If there is no distance between them, it cannot have moved from one to the other. For something cannot have moved except by moving from somewhere to somewhere else. And while it is at the place from which it is to move, it is not yet in motion from the one to the other. And while it is at the place to which it is to move, it is no longer in motion, but is already there. It can only then be in motion when it is between the places from which and towards which it is to move. If then it is at one instant at the place from which it is to move, and at another instant at the place towards which it is to move, but it was never somewhere between them, it will have moved without ever moving. But that is absurd. Again, if the points are different at which it has momentum along different tangents, and it occupies their places at different instances, then while it is at the one, it cannot be at the other, and vice versa. But if it cannot go from one point to the other without moving, and it cannot ever be moving without being somewhere between them, then if there is no distance between them, it cannot move from one to the other. For if it moves from one point to any other point, and is at the one point at one instant, and at the other at the quote-unquote next instant, but is never passing between them, it will at the first instant not yet have moved, and at the second instant have already moved without ever moving. But something cannot have moved without ever moving. Therefore, whether or not there is any distance between any two different points at which it has momentum along different tangents at different instances, it cannot have moved from one to the other curvilinearly. Now, I wish to emphasize that the illegitimate use of infinitesimals is not merely a question of accurate or inaccurate calculation. This I don't think has been previously discerned, that there is a difference between the instrumental use of infinitesimals to approximate the calculation of an irregular figure and their use as accompanied by a conceptual assertion. How infinitesimals factor into Newton's argument that curvilinear motion might be caused by only rectilinear forces should reveal just that. Newton attempts to make areas admittedly unequal become equal upon being infinitely diminished for a very specific purpose. Again, consider the reason why, and consider how the conceptual assertion that accompanies the maneuver differs from what is equated mathematically. He required the summation of the areas of a multitude of parallelograms to become equal to an area under a curve in order to equate a multitude of rectilinear motions with a single curvilinear motion. For since the base of each parallelogram stands for a distance moved rectilinearly, a summation of rectilinear distances might become equal to the length of a curvilinear line if each distance traversed rectilinearly is diminished and the number of rectilinear distances is increased ad infinitum. However, whether or not the summation of motions along a multitude of rectilinear lines, quote-unquote, sweeps out equal areas in equal times, as does a single continuous motion along a curve, would not by virtue of that render the multitude of rectilinear motions either a single continuous motion or curvilinear. I cannot see how we have anything else here than a unique form of equivocation before unknown, whereby quantitative equality is equivocated with qualitative similarity, instead of the usual conflating of one meaning of an ambiguous term with another. Again, once more, consider why he so explicitly insisted that all motion is altered rectilinearly, that he insisted to make as a law of motion that a motion can only be altered rectilinearly, that a force can only alter a motion rectilinearly. Why he so explicitly insisted that, such as to make it a law of motion, is first principles. That is necessary in order to assert that there are no forces other than those which move terrestrial bodies rectilinearly, and that the planets are neither moved by different kinds of forces, nor are they themselves of a different kind of substance. And consider also that such a suspicious mathematical procedure is contrived to then account for curvilinear motion at all, which is ruled out by those first two laws of motion. For if a motion can only be altered in the direction of a right line, law 2, and everything in motion continues moving in a right line unless it is altered by another force, law 1, but that again would only redirect its motion along another right line, then how, by Zeus, can anything even possibly move curvilinearly? And if the planets quite obviously move curvilinearly, then how can it be that a motion can only be altered in the direction of a red line? And that everything continues moving in a right line unless its motion is altered by another force, which again would only alter its motion rectilinearly. The success of the entirety of the theory depends on ruling out forces that cause curvilinear motion, and on restricting the causes of motion to only those forces which can alter a motion rectilinearly. But that anything might then move curvilinearly at all is also ruled out by the same presuppositions. The use of infinitesimals is contrived to at once claim that forces can only alter the motion of something rectilinearly and to simultaneously retain the contradictory position that rectilinear forces might cause curvilinear motion in infinitesimal increments. There would thus be no need to resort to infinitesimals if you weren't already in such a conceptual mess. But the concepts of infinitesimal distances, infinitesimal parts of time, infinitesimal increments of motion are no less shrouded in obscurity, nor do they resolve the conceptual dilemma. For are these infinitesimals, fluxions, and nascent quantities of any span whatsoever? If they are, then each part of the motion must be rectilinear. Look, are these infinitesimals of any span whatsoever? If they are, each part of the motion must be rectilinear. But then the whole motion cannot be of a continuous curve. While if they are not, then there will be nothings, and consequently motion will be discrete. Lines will be composed of points, and intervals of time composed of instances. But how can something at an instant move from anywhere to anywhere else? For while it is at the one point, it cannot be at the other, and vice versa. That much is clear. If then it moves from one point to the other at an instant, and when it is at the one point, it cannot be at the other, the instant will be divided. But that is impossible. And if the instant is not divided, but at the one point it can't be at the other and vice versa, then at the same instant it will both be and not be at each of the points. But that is absurd. And how can something be at one point at one instant and at another point at the next instant? For if, when it is still at the first point, it cannot yet be moving from the one to the other, and when it is at the other point, it cannot any longer be moving from the one to the other, for it is already there, then it can only be moving from the one to the other while it is somewhere in between them. Since again, while it's at the first point, it is not yet moving, and when it's at the second point, it cannot any longer be moving, for it is already there. It can only then be moving while it is somewhere in between them. It can only then be moving from the one to the other while it is somewhere between them. But if it is never anywhere between them, and there is no time between the two instances, it will have moved without ever moving. But that is absurd. That a mathematician might feign to calculate the quantity of its so-called instantaneous velocity cannot possibly overrule these conceptual difficulties. On the contrary, the weight of the arguments would render the supposed calculation meaningless and nonsensical. But if a mathematician were to attempt to prove that motion is discrete with reference to a calculation of an instantaneous velocity, that would not differ so much from the role played by the mathematics in Newton's maneuver. As far as I know, mathematicians do not always provide such a calculation with an underlying conceptual assertion, but there are problems there too. However, Newton's mathematics was accompanied by a conceptual proposition, as the point of his mathematical proofs was just that, a conceptual proposition, conceptual claim. Again, I wish to stress that the questionable and suspicious nature of infinitesimals does not, in cases where they are accompanied by a conceptual assertion, come down to the question of their technical accuracy or inaccuracy in calculation. Nor could Newton's argument be verified by confirming his mathematical accuracy. For Newton does not use them in his Principia Mathematica as a calculative device. Find instead that nothing is calculated at all. Their function is rather that of a sleight of hand, whereby nothing is affected but the smoothing over of a contradictory proposition. For why should unequal areas be diminished ad infinitum and then declared equal at the moment they vanish? That a geometrician would even make such an utterance is impossible. No statement could be more foreign from geometry. Again, in Newton's conception, the area of each parallelogram represents the area swept out by a motion. And since the summation of the parallelograms is quite obviously unequal to the area under the curve, the difference needs to be made up for if the summation of a multitude of rectilinear motions is to amount to a single continuous curvilinear motion. So it is simply declared that if they are diminished in magnitude and increase in number ad infinitum, then the distance covered by a multitude of rectilinear motions will be equal to the distance of a motion along the curve. No consideration is given how a leap to something qualitatively different is made by a quantitative difference in the number and length of the rectilinear lines, nor how the motion of something always moving rectilinearly can as a whole be curvilinear. The maneuver is more akin to that of a stage magician than a logician or a geometrician. For the question does not in any way come down to the accuracy of his mathematics, but to an arbitrary and absurd hypothesis from which the conclusion does not even in any way follow. It is one thing to approximate the calculation of the area of a circle by inscribing inside of it rectilinear polygons and circumscribing similar polygons outside of it, and determining that the area of the circle must fall somewhere between those of the polygons which are exceeded by and those that exceed it, by the method of exhaustion. And that is the limit and extent of the usefulness of calculus, as far as I could tell, not as a science, but as a knack of approximating the calculation of irregular figures and curves. But when from the claim that the length of the circumference is approximately the length of the summation of a great many minute sides of a polygon, a clumsy step is made, which has nothing to do with any such calculation, in claiming that something moving along the sides of such a polygon is moving curvilinearly, whilst going to great lengths to deny that any force can move anything curvilinearly. The theory is not less deceptive and malicious or sophistic than contradictory. We find once more that mathematicians attending to the signs and rules for manipulating equations they all too often attend not to the things the signs stand for, that quite easily they are betrayed into impossibilities and contradictions by following an arbitrary process of manipulating symbols. For the rules of manipulating signs in an equation are not the rules of logic. And if the rules for manipulating equations tell you that if both sides of an equation are squared, or better yet, if the square root of both sides is taken, that both sides of the equation then remain equal. Yet, if there is no definite quantity whatsoever that is a square root of either of the sides of the equation, if one of them is their square root is irrational, the result will not be that the sides of the equation remain equal. For one of the sides being irrational and through indefinite cannot be equal to anything definite. And if both are then indefinite, then neither can they be equal. Nor will the indefinite quantity thus expressed be in any way known. For what is indefinite cannot be known. Here again, it would be appropriate to call upon George Berkeley and to ask, along with him, quote, whether it would be righter to approximate fairly than to endeavor at accuracy by sophisms. Now that is the end of the section I wish to read. But I should read the title of the next section, because this shows why that is so important. The next section is entitled, If the Curvilinear Motion of the Planets Cannot Be Caused by Rectilinear Forces, then either the luminaries must themselves be divine, or they must be moved by a divine force altogether different from the forces which move terrestrial bodies rectilinearly. And Newton had this in mind when he chose as his first two principles, or his laws of motion, that a force can only alter a motion rectilinearly, that a motion always continues moving rectilinearly. He had in mind obscuring Aristotle's proof of the unmoved mover and the eternal motion of the eternal motion of the circular moving luminaries. But if the circular motion of the luminaries cannot be caused by any combination of rectilinear forces, then they cannot be moved by constraint in the manner in which terrestrial objects are impelled from without by an external force. Nor, speaking generally, can the same kind of forces which terrestrial bodies are supposed to be moved by rectilinearly cause the circular motion or the curvilinear motion of the heavens or the planets.